Write the electronic configuration of an element having atomic number 12. So atomic number equal to 12, which means equal to protons. Number of protons are also equal to number of electrons. So number of electrons 12. Now we need to distribute them. So we have the K, L and M shell. So 2 electrons, there are 12 electrons to be distributed. So 2, 8, we become 10, 2 are left. So 2 plus 8 plus 2 is 12. So electronic configuration equal to 2, 8, 2. Write the distribution of electrons in carbon atom. So first you must know atomic number. So carbon atom atomic number equal to 6. So when we distribute, we have K, L. So this is 2 and 4. So electronic configuration (2, 4). That's of carbon atom. Write the electronic configuration of sodium atom, atomic number 11. Sodium atomic number is 11, means protons 11. Protons 11 means electrons 11. So when we distribute, we have K, L, M, N shells. 11 electrons to be distributed. 2 in the first, 8. So it becomes 10. 1 is left. So we don't need this shell. So electronic configuration (2, 8, 1). If both the K and the L shells of an atom are full, what is the total number of electrons in an atom? So we have the K and the L. We know the K can take in 2 electrons and the L can take in 8. So 2 plus 8, there must be 10 electrons in total. So we can say number of electrons equal to 10. An element has 2 electrons in the M shell. What is its atomic number? So there we have K, L and M shell here, and 2 electrons in the M shell. So 2 electrons here, which means the earlier ones must be already filled. There must have been 8 here, 2. Now let's add up and see how many electrons this has. 12 electrons. 2 plus 8 plus 2. Let me repeat this question again. So we have the K, L, M shell, and they said there are 2 electrons already in the M shell. So here there are 2 electrons. That means that L must be filled, otherwise M would not have been filled. So there must have been 8 and 2. So total become 12. So number of electrons equal to 12. If number of electrons is 12, protons also 12, atomic number 12. What do you mean by the term electronic configuration of an element? Electronic configuration is a distribution, or you can say arrangement, of electrons in the various shells or energy levels of an atom. Next they say give the electronic configuration of oxygen, atomic number 8. So we have oxygen, atomic number 8 means protons 8, and protons are equal to electrons, so electrons also 8. Let us distribute them. We have shells K, L, M and N. Let's say how many shells we require. We have to distribute 8 electrons. 2, 6 are left. 6. So we don't require these 2 shells. This would be the electronic configuration of oxygen. You'll say 2, 6. Name the scientist who described the arrangement of electrons in an atom. That was given by Bohr, Neil Bohr and Bury. What is the maximum number of electrons that can be accommodated in the K shell? Now the K shell is the first shell. First shell means n equal to 1, and maximum electrons is given by the formula 2n square. So that would be 2, your n would be 1 square. So maximum electrons that can be accommodated in the K shell is 2. So maximum electrons accommodated in K shell equal to 2. Find the maximum electrons accommodated in the L shell. Now for the L shell is the second shell, and because it is a second shell, n equal to 2, and we know the formula for maximum electrons is given by 2n square. So now this would be 2, your n is 2, 2 square, so it would be 8. So the maximum electrons in L shell is equal to 8. Find the maximum number of electrons in the M shell. So M shell, third shell, means n equal to 3. Formula for maximum electrons 2n square. 2, this would be 3 square. So 2 into 9, 18 electrons. So M shell can accommodate maximum 18 electrons. However, it does not accommodate 18 electrons. It accommodates 8 electrons and it is stable. But the maximum it can accommodate is 18. Now the maximum number of electrons for the N shell. So for N shell is the fourth shell. That means n equal to 4. And maximum electrons is given by the formula 2n square. So 2, and here our n is 4, so 4 square. So it is 2 into 16, that is 32. So N shell can accommodate 32 electrons. What is the maximum number of electrons that can be accommodated in the innermost shell? Now remember, the innermost shell is the first shell. Innermost shell is the first shell, which is a K shell, and we know K shell can accommodate 2 electrons. And then we must know the outermost shell. Now if the outermost shell is other than the K, if outermost shell is like L, M, N, then the maximum electrons that or stable electrons would be 8. Although they can accommodate more than that, once they accommodate 8 electrons, they are stable. They will not accommodate more than 8 electrons, although their capacity is much more than 8. From the symbol, we have the symbol P, 31 and 15. So the 31 is mass number, and the 15 is atomic number. Now we know the mass number is equal to protons plus neutrons. So we can say now protons plus neutrons is 31, right? And atomic number is number of protons. So this is protons. So protons equal to 15. If protons is 15, electrons is also 15, because protons equal to electrons. Now let's do the electronic configuration. K, L, M, N. So we have to distribute 15 of them. So 2 in the first, 8 become 10, and 5. So we don't require the N shell. So electronic configuration of phosphorus will be 2, 8, 5. Have you noticed one thing? You do not require 31. You require the atomic number is important for configuration, not the mass number. It is with the atomic number that you will do the electronic configuration. So here for the answers, here the mass number was 31, atomic number was 15, and the configuration was 2, 8, 5. What is the electronic configuration of hydrogen atom? Hydrogen atom was atomic number 1. So we have the K shell, 1 electron in the K shell, that's it. There's no L, M, N shell. So electronic configuration of hydrogen equal to 1. What is the atomic number of an element having 7 electrons in the M shell? So that is K, L, M. And in the M shell it has got 7 electrons. That means there must have been 8 in the L and 2. Now you have to add up 2 plus 8 plus 7, that is 17. So 17 electrons, that means also 17 protons, which means 17 equal to atomic number. Atomic number, number of protons. An element has atomic number 12. How many electrons are present in K, L, and M energy shells? So atomic number 12. So we have the K, L, and the M shell. Let's distribute 2, 8, now we got 10 and 2. So let's add and see if it's right. 2 plus 8 plus is 12, right? So that's correct. So this is its In the K shell there are 2, in the L shell there are 8, in M shell there are 2. An element has atomic number 13. So let me write that. Atomic number 13 means what? Protons equal to 13 and mass number 27. Mass number equal to 27, which is protons plus neutrons. How many electrons are there in each atom? So number of electrons equal to number of protons, and we have seen the number of protons is 13, so the electrons will be also 13. How are the electrons distributed in the various energy levels? So let's do the electronic configuration. That is K, L, M. There are 13 of them to be distributed. So 2, 8, 3. So electronic configuration will be 2, 8, 3. Add up, you get 13. The electronic configuration of an element is 288. What is its atomic number? So electronic configuration equal to 288. So electrons will be number of electrons (2 plus 8 plus 8), and that is 18 electrons. So if the electrons are 18, the protons also will be 18. And number of protons is atomic number. Atomic number is 18. Now the element that has got atomic number 18 that you need to remember is argon. It has a symbol Ar. Atomic number 18 is argon. Just like you have roll numbers, elements also have got roll numbers. If you say 18, it has to be argon and no other element. If you say like 6, it has to be carbon and no other element. If you say 20, it has to be calcium and no other element. Write the distribution of electrons having atomic number 18. So atomic number 18 means protons 18. A protons 18, electrons also 18. So let's distribute them. K, L, M. Maybe N also. We'll put it. So we have 2, 8, 10, 8. So that is the electronic configuration of electronic distribution. Distribution of electrons. 2, 8, 8. State the number of electrons present in the outermost shell of neon. So we have neon. You first must know atomic number. Without atomic number you cannot do anything. So atomic number is very fundamental property. Atomic number equal to 10. So next we will just put here the orbits K, L, M. Maybe we require N. So we have 10 electrons to be atomic number 10. So electrons also will be 10. So it's 2, 8. That's what we got, the 10. So the outermost shell will have 10 electrons. Outermost shell equal to 8 electrons. Next we go to chlorine. Now for chlorine, its atomic number is 17. Seventeen means the proton 17. If protons are 17, electrons also 17. So to make the electronic configuration now, we have K and L. We'll have 2, 8, and we require another one also, because 10, we require one more. So that will be 2, 8, and 7. So when you add them up, you see 17. Outermost shell has got 7 electrons. So here, outermost shell has 7 electrons. Which shell of an atom has 8, can have maximum 8 electrons? We saw the L shell. L shell. Why? Because for L, n equal to 2, and the maximum electrons are 2n square, that is 2 square, and that is 8. So the answer is L. And 32 electrons, and that would be the N shell, because for the N shell you have n equal to 4, and that is 2 4 square, which is 32. So the N shell has 32 electrons maximum, and the ML shell has 8 electrons. Name the shell that has 2 electrons. 2 electrons is the first shell, K shell, because n equal to 1, 2n square means 2 1 square, so 2 electrons. And name the shell that has got 18 electrons. So 18 electrons, it will be the M shell, because for M shell n equal to 3, it is 2n square, 2n, n is 3 square, and that is 18. Remember, we have shells K, L, M, N. Here n equal to 1, this is 2, this is 3, this is 4, and the maximum electrons is 2n square. So if you put the formula here, you'll get 2, you get 8 here, you get 18 here, and you get 32 electrons, maximum electrons. The maximum number of electrons accommodated in the L shell. So for L shell, n equal to 2, so maximum electrons is 2n square, 2 square, which is 8 electrons. And next is for the M shell. M shell, n equal to 3, so it is 2n square, 2 3 square, 2 into 9, 18 electrons. An element has atomic number 11, so atomic number 11. Remember, atomic number is protons. Mass number 23, means protons plus neutrons. What is the arrangement of its electrons? So first let's find out all the 3 subatomic particles. So we know protons here, we know mass number is 23. So we'll do now protons plus neutrons 23. Protons is 11 plus neutrons 23. So neutrons 23 minus 11, neutrons is 12. So this atom, the atom has 3 subatomic particles, that is protons, electrons and neutrons. We saw that the protons were 11, the electrons to be also 11, and the neutrons is 12. Now we have to find the arrangement of the electrons. 11. So we'll distribute them 2, 8, 1. That is 11. Those are distribution of electrons. Next question is, what is its nuclear composition? So in the nucleus we have the protons plus the neutrons. So protons we saw are 11 and neutrons are 12. So nuclear composition is 23.